Alright, so what we're going to check out today is kind of the introduction of the sinusoidal unit. I like to attack sinusoidals very, very directly and not do it piece by piece, but instead just sort of dive in and do everything at once. So I'm going to stray from the notes a little bit to begin with, but we will get right back to them. Now, let's for an example, or rather, let's try to graph the motion of a circle. So what I'd like you guys to imagine is that you're on a Ferris wheel. And the Ferris wheel is a very, very common example that's used in this. So you're right here, you're all happy, yay, I'm on a Ferris wheel. And we're going to jump on at the middle. So at time 0, you're on the middle of the Ferris wheel. Then what happens is a certain amount of time passes, and you move, and you get to the top of that Ferris wheel. So we'll go after about 3 units right here, and then we'll move up to the top of the Ferris wheel, and we'll put another little dot there. So yeah, I'm at the top of the Ferris wheel. Then as time passes, you keep on going back around, and what happens? You may even have a little balloon now that's attached. But then you end up back in the center, so we go another 3 units, and you're back at the center of the Ferris wheel. And then you reach the bottom of the Ferris wheel. You're sad because you dropped your balloon. So we move down here, and then after another 3 units right here, we're at the bottom of the Ferris wheel. And then after another 3 units, we end back in the middle of the Ferris wheel. So now what I want to do is I want to find a way to plot that motion. So I'm going to connect everything. Now this isn't the best way that I can explain it, but it's good enough and it's the simplest. We're going to use curves because I'm moving in a circular motion here instead of just a direct motion. So I'm going to attach right there, and then I'm going to attach right there, and then we go down right there, and then we connect up right there. And what we get is we get what's called a sinusoidal curve. And what this sinusoidal curve is it's a way of plotting motion when you're working with circles. Now, a couple things that I'm going to bring up about the sinusoidal curve. If we look at it, and I'm just going to quickly switch to another color right here, you see it very, very evenly breaks into quarters right here. And when we're looking at sine and cosine, we'll notice that it's going to break into quarters. Another thing, if I draw this dotted line through the middle, you'll notice that it's the same distance from the middle to the top as it is from the middle to the bottom. So what happens right here is this distance is the same as this distance. Now we're later going to call this amplitude, but that's for the next lesson. I just wanted to bring up that you could break this down and sort of look at how it breaks down into these individual quarters. Okay, you'll also notice that each piece kind of self-replicates. It's just in a different orientation. Now, moving on. If you guys, oh, there we go. So if you guys grab out your graphing calculators, and what I want you to do is look at y equals sine x. And for your window setting, you're going to have y max as being, we'll just set it to 3. The y min will be -3. And then we're going to have x min as either -2 pi or -360, depending on if your calculator is in degree and radian. And our x max will be equal to 2 pi or positive 360. Again, this is depending on if your graphing calculator is in degrees or radians. So right here, what I'm going to do is I'm just going to put a couple little markers on here every 2 units. And then I'm going to label this right here as being +1. I'm going to label that right there as being -1. And then right here with this last one, we're going to say that that's 360 degrees, or that's 2 pi radians. Then for y equals sine x, it starts here, it goes to the top, goes to the middle, goes back down to the bottom, and then goes back to the middle. So we get a curve that looks something like this. Same thing, if I go backwards on this, it goes to the bottom, goes to the middle, goes to the top, and goes back to the middle. And this is what we'd call our sine wave. Now you guys will notice if you expand the window, it's going to go on forever and ever and ever in both directions. So down and up forever and ever and ever in both directions. Another thing that you guys will notice is my maximum of sine x is 1 and my minimum of sine x is -1. So if we're looking for the sine of some angle, it's actually never going to be above 1, nor will it be below -1, assuming I'm just working with the function sine x. We'd actually say that sine x is bounded by 1 and -1. Now, the next thing to quickly touch on, if you guys remember your unit circle, well, where was sine x equal to 0 at the halfway point of 100?